entire span. So we take cantilever like this. Fixed from this side, and this cantilever this point is point A. Point A is a fix. So point B is a free end, and over this entire length there is a uniformly distributed load. Like this, the value of this load is small w newtons per unit meter. So this point is point B. Okay. And the length is L, and the deflection, it will deflect like this. The cantilever will bend downward like this due to this load. It will bend, and the maximum deflection will occur over here. This is YB, the maximum deflection, and the slope, the maximum slope will be at point B. So if I draw the tangent to this point, so this is, let's say, B1, I applied tangent to this B1, this will go like this, and this angle over here is theta B. Okay, so now the objective is we have to apply the double integration method to determine the equation of slope and deflection for this cantilever, right? And also find out the maximum slope theta B and maximum deflection YB. So this is the objective. So we start with the equation of elastic curve. We start from this side. The equation of elastic curve is given as EI d square y upon dx square equal to minus m. So I call it as equation number 1. Now, what I do, I will first determine the value of bending moment and put over here. For that, I make section. So I take section in this cantilever like this. You can take anywhere. So let's say I take over here. I pass one section and draw the free body diagram. I take this section from point A. So this distance is x. At any distance x, I pass one section and draw the free body diagram. I draw the free body diagram of this right hand side. So like this, and so this is the load on this right hand side. Okay, and over here, this is the bending moment m that I have to calculate. Now this distance must be L minus x if total length of the cantilever is L. I also draw the total length of the cantilever. So this is the total length of the cantilever L. So ये जो बाकी का distance बचेगा, that will be L minus x. Now this is a free body diagram of right hand side of the cantilever. So I take moments about this point. So I write sum of moments about point x equal to 0, positive, clockwise. So I apply this equation and determine the value of m. So first I write this clockwise bending moment. So I write over here clockwise bending moment is m. So this one, right? Then the moment due to this w. This load is w newtons per unit meter. So this is acting downward. First of all, it will rotate this beam segment in clockwise direction about this point. Okay, so total load will be w into L minus x. I write plus w into L minus x. This is the total load. multiply by, so this load will act at the centroid, तो यहाँ पे सेंटर पे लगेगा ये ऐसे करके, so this is W into L minus X, so this is the total load acting at the center. Now from center to this point, so I have to take this distance, तो ये वाला डिस्टेंस मेरे को लेना पड़ेगा, दिस विल बी L minus X divided by 2. So I multiply by this distance L minus X divided by 2. So ये total ये वाला जो distance है, this is L minus X, उसका हाफ हो जाएगा. तो इस लोड को मैं इससे मल्टीप्लाई कर दूंगा, I get the total moment because of UDL. Then there is no other force, this is equal to 0, or I can write M will be equal to minus W L minus X square divided by 2. So this is the law of bending moment which will be applicable in this cantilever. So I call it 2. Right? Put equation number 2 in 1. एक नंबर में पुट करेंगे, यहाँ पे इसको पुट करेंगे, तो मेरे पास इक्वेशन क्या बन जाएगी, EI d square y by dx square equal to minus m. Now this minus and this minus, they both will become plus, and I get W by 2 L minus X square. I call it 3. Now this is the first step. ये हमारा पहला स्टेप है कि हमने बेंडिंग मोमेंट को डिटरमिन करना है, राइट, और वैल्यूज पुट कर देनी है इक्वेशन नंबर 1 में. So this is first step of this. Now second step is that you integrate. So I write integrate equation number 3. तो 3 नंबर इक्वेशन को मैं इंटीग्रेट करूंगा. इफ आई इंटीग्रेट दिस इक्वेशन ऑन लेफ्ट हैंड साइड आई गेट EI dy by dx, and on this side I get minus W by 6 L minus X cube plus C1, where C1 is constant of integration. Okay, I call it 4. मैं 4 नंबर इक्वेशन लूंगा. सी दिस L minus X का जो इंटीग्रेशन है, दैट विल बी L minus X क्यूब डिवाइडेड बाय 3. तो ये 3 से 2 मल्टीप्लाई हो जाएगा, आई गेट 6, और ये माइनस एक्स का माइनस यहाँ पे आ जाएगा. ओके, सो दिस इज इंटीग्रेशन ऑफ दिस. तो अब मैं यहाँ पे C1 इज कांस्टेंट ऑफ इंटीग्रेशन, आई विल डिटरमिन दिस कांस्टेंट ऑफ इंटीग्रेशन फ्रॉम बाउंड्री कंडीशन. नाउ व्हाट इज द बाउंड्री कंडीशन फॉर स्लोप? हमारे पास स्लोप की बाउंड्री कंडीशन क्या है? एट x इक्वल टू 0 योर dy by dx equal to 0. Now this is the boundary condition for slope. So I put this boundary condition in equation number 4. So 4 नंबर इक्वेशन में इसको रखेंगे, तो मेरे पास ये आ जाएगा EI into 0 equal to minus W by 6 L minus 0 का क्यूब plus C1. Right? So if you simplify this, you get 0 on this side minus W L square. This is WL cube by 6 plus C1. This is cube. Then C1 will be equal to WL cube by 6. So first constant of integration, so this will be equal to WL cube by 6. I put this value again in 4 back, put in 4 again. 4 नंबर इक्वेशन जिसमें C1 लिखा है वहां पे C1 की वैल्यू पुट करेंगे. I get EI dy by dx equal to minus W by 6 L minus X का क्यूब plus C1. Now what is C1? It is WL cube upon 6. Now this is the final equation of slope. I call it 5. सो दिस इज द फाइनल इक्वेशन ऑफ स्लोप, जहां से हम किसी भी पॉइंट की स्लोप कैलकुलेट कर सकते हैं, राइट। देन स्टेप नंबर 3, I will determine the maximum slope later on. Step number 3, integrate again. Integrate 5 नंबर इक्वेशन को फिर से इंटीग्रेट करेंगे. On this side I get EIY. This will be equal to small w. ये हो जाएगा L minus x raised power 4 divided by 4, and 4 into 6 I get 24. So 24 plus. So minus and minus become plus in the integration. Plus WL cube by 6 into x plus C2. So C2 is another constant of integration, जिसकी वैल्यू मैं डिटरमिन करूंगा बाउंड्री कंडीशन से. I call it 6. So now apply the boundary condition for deflection. So what is that? That is at x equal to 0, y will be equal to 0. So if I put y0 over here, x0 over here and x0 over here, I get C2. So अगर मैं करूंगा तो C2 की वैल्यू आ जाएगी माइनस w L raised power 4 upon 24. Okay. So put this C2 over here in 6. Put in 6. So if I write the final equation of deflection. EIY equal to w upon 24 L minus x raised power 4 plus WL cube by 6 into x plus C2. Now C2 is minus WL4 upon 24. I call it 7. Now this is the final equation of deflection for this type of cantilever. Okay. So this is step number 3. Step number 4 is determine the maximum slope and maximum deflection. Now write the maximum slope and deflections will occur at free end. Free end of the cantilever, that is at x equal to L. तो हम क्या करेंगे, x इक्वल टू L पुट करेंगे पहले 5 नंबर इक्वेशन में यहाँ पे, और यहाँ पे पुट करेंगे तो हमारे पास मैक्सिमम स्लोप आ जाएगी. फिर हम x इक्वल टू L पुट करेंगे इस इक्वेशन में 7 में. आई राइट फर्स्ट पुट इन 5, वी गेट EI. So dy by dx, which is your slope at point B, equal to minus w by 6 L minus L का cube plus WL cube by 6. Now if I simplify, I get theta B. So this is theta B. dy by dx is theta B. So theta B will be equal to, ये 0 हो जाएगा, WL cube by 6 EI नीचे आ जाएगा. So this is the maximum slope. Similarly, put in 7. 7 नंबर इक्वेशन में पुट करेंगे, यहाँ पे L x इक्वल टू L पुट करेंगे, ये सारी टर्म 0 हो जाएगी. यहाँ पे L पुट करेंगे तो ये हो जाएगा WL क्यूब इंटू L4 डिवाइडेड बाय 6. तो ये दोनों सब्ट्रैक्ट हो जाएंगे. सो आई गेट, मैं डायरेक्ट वैल्यू लिख देता हूँ, अगर आप करोगे तो ये वैल्यू आ जाएगी स्मॉल w L रेज पावर 4 अपॉन 8 EI.